What up, hackers and cybersecurity enthusiasts? Today we're going to be taking a look at OWASP Top 10. I'm going to start moving into working on more OWASP Top 10 stuff. The goal here is to do OWASP Top 10, get very familiar with it, get some expertise in it, and then move on to bug bounties. So I'll probably go over this OWASP Top 10. This is an easy machine or easy path on TryHackMe. And we'll go over the top 10 vulnerabilities and 10 most critical web security risks. And then from there, in the next videos in the series, we'll probably go more specifically into each type of vulnerability and do labs based off of that. With that being said, we're at TryHackMe right now, and we are at OWASP Top 10. This is the easy version. There's a medium version as well. Let's go ahead and start the box here. We'll let this load, and I will see you when it's done. Alrighty, we've launched the machine. It's now loaded, and this is kind of the generic view. Now, this is too much to fit on the screen, right? So what we're gonna do here, it's been a while, but I believe we need to open. What the fuck do we do? There's a way to actually open this. This is gonna close the machine. Okay, so click on view in full screen, and we'll actually just get the box. Much easier to read and actually manipulate everything in here this way. Make my fucking head smaller. We'll exit split view here. Where we can actually view what's going on. Alright. Now that I've fixed the resolution issues and we have our full machine here as well, let's go ahead and look at what we're doing. Introduction. OWASP Open Web Application Security Project. This room breaks each OWASP topic down and includes details on what the vulnerability is, how it occurs, and how you can exploit it. You'll put the theory into practice by completing supporting challenges. We have injection. That would be one. We have broken authentication, sensitive data exposure, XML, broken access control, security misconfigurations, cross-site scripting, insecure deserialization, components with known vulnerabilities, and insufficient logging and monitoring. This room has been designed for beginners and assume no previous knowledge of security, so it shouldn't be very hard for us to do. However, as I mentioned before, the whole idea here is to move from CTS only into gaining some expertise in OWASP Top 10. That way we can start doing bug bounties. Let's go ahead and take a look at this box. We'll go ahead and click complete. Task 2, accessing machines. Some tasks will have you learning by doing, often through hacking a virtual machine. However, access to these machines, blah, blah, blah. We've already launched our machine. All right, task 3, let's begin. We have severity number 1, which is injection. I'm going to do notes as well on the side, so it'll take a little bit longer, but with the while I'm taking notes, the whole point of me taking notes is so that when we move on to bug bounties, we can take a look at our notes, and then we'll be able to have something that's long lasting and help us actually hack the machines. Severity 1, injection. Injection flaws are very common in applications today. These flaws occur because user-controlled input is interpreted as actual commands or parameters by the application. Injection attacks depend on what technologies are being used and how exactly the input is interpreted by these technologies. Some common examples include SQL injection. This occurs when user-controlled input is passed to SQL queries. As a result, an attacker can pass in SQL queries to manipulate the outcome of such queries. We also have command injection. This occurs when user input is passed to system commands. As a result, an attacker is able to execute arbitrary system commands on application servers. If an attacker is able to successfully pass input that is interpreted correctly, they would be able to do the following: access, modify, and delete information in a database. When this input is passed into database queries, this would mean that an attacker can steal sensitive information such as personal details and credentials. Also able to execute arbitrary system commands on a server that would allow an attacker to gain access to user systems. This would enable them to steal sensitive data and carry out more attacks against infrastructure linked to the server on which the command is executed. The main defense for preventing injection attacks is ensuring that user-controlled input is not interpreted as queries or commands. There are different ways of doing this, using an allow list and stripping input. So for an allow list, when input is sent to the server, this input is compared to a list of safe input or characters. If the input is marked as safe, then it is processed. Otherwise, it's rejected and the application throws an error. Stripping input. If the input contains dangerous characters, these characters are removed before they are processed. Dangerous characters or input is classified as an input that can change how the underlying data is processed. Instead of manually constructing allow lists or even just stripping input, these are various libraries that perform these actions for you. Okay, let's go ahead and move on to task 4, severity number 1, OS command injection. Command injection occurs when the server-side code, like PHP in a web application, makes a system call on the hosting machine. It's a web vulnerability that allows an attacker to take advantage of the made system call to execute operating system commands on the server. Sometimes this won't always end in something malicious, like a who am I or just reading of files. That isn't too bad, but the thing about command injection is it opens up many options for the attacker. The worst thing they could do would be spawn a reverse shell to become a user that the web server is running as. Simple netcat echo or netcat execute bin bash is all that's needed, and they own your server. Some variants of netcat don't support the E options. You can use a list of these reverse shells as an alternative. Once the attacker has a foothold on a web server, they can start the usual enumeration of your systems and start looking for ways to pivot around. Now that we know what command injection is, we'll start going into different types and how to test for them. Perfect. Task 5, command injection practical. What is command injection? Blind command injection occurs when the system commands made to the server does not return the response to the user in the HTML document. Active command injection will return the response to the user. They can be made visible through several HTML elements. Consider a scenario. Evil Corp started development of a web-based shell but has accidentally left the internet exposed to the internet. It's accidentally left web-based shell is accidentally left exposed to the internet. It's nowhere near finished, but contains the same command injection vulnerability as before. This time, the response to the system call can be seen on the page. They never learn. Just like before, let's look at the sample code from evilshell.php and go over what it's doing and why it makes active command injection. See if you can figure it out. I'll go over it below just as before. evilshell.php code example. So here's PHP code. If it says get command string is equal to get command string, let's look for a command string here, and pass through the command string it's trying to find, and echo error. Okay, so fucking the command's not entered. In pseudocode, the snippet is doing the following: check the prior command string is set. It's not set. Just right here. If it literally, this won't output anything because you can't output stderr, but PHP doesn't let you have a try without a catch. Ways to detect active command injection. This is what we're after. We know that active command injection occurs when you see the response from the system call. In the above code, the function pass-through is actually what's doing all of the work here. It's passing the response directly to the document. So you can see the fruits of your labor right there. Since we know that, we can go over some useful commands to try to enumerate a machine a little bit better. The function call here to pass through may not always be what's happening behind the scenes. But I felt it was easiest, least complicated to demonstrate this vulnerability here. Commands we could try, who am I, ID, these are all basically commands, system commands. In Linux, obviously, I didn't even see the Linux part. But yeah, these are all Linux commands, these are all Windows commands. So who am I, ID, IP config, or ifconfig, username A is going to tell you what user, and PS, who am I, var, ipconfig, tasklet, nestat will show pretty much all the machines on the network, and it will also show some network data. Complete the questions below. Navigate to this IP 1010.3.61/evilshell.php. So what we're going to do is we're going to grab this here. It's an insecure website. You can see that already. Go over here to our other bot, which is Kali Linux, because I wouldn't suggest launching this in whatever VM they give you, just because that's not practical and that's not what you're going to use in the wild. So you're not doing yourself a favor, put it that way. Well, here we'll load the Kali Linux machine. All right. So check out this evil corp. Well, it doesn't want to paste, so that's fine. All right, here is the evil shell. Now, this is a basic submission application, if you will. Now, this could also kind of like simulate a login, but that would there would be a little bit more code behind it. But essentially, it's a search or submission. So you could do like hi string is equal to hi command string is equal to hi. That's not doing anything, right? Well, my www data. Okay, well that would mean that it is actually, here we see it is vulnerable to command injection. Which command injection is that? That is active command injection, okay? So that's active command injection because we can see what's going on. Let's try some other codes here. ID, I'm just going to copy these. We'll go through all of them a little easier. So we do ID. UID is equal to, user ID is equal to 33, www data, group 33. This will tell us the IP address, ifconfig/IP address. This is how you do it in Linux. Copy that. ifconfig/IP. You could probably just do ifconfig. Yeah, exactly. So 1010.3.61 is telling you the IP. Shows the domain here. 80 running on 1010.3.61. Try the IP ifconfig/IP. See if we get a different result. ADDR. Yeah, okay, well, you get it. ifconfig works. Alright. What strange text file is in the website root directory? Alright, so let's go ahead and do ls. As its reverse shell, we try that. We get drpepper.txt. That's the answer. No, they should have added that here. Like, that's actually crazy. How are you supposed to know that? Anyways. Yeah. Bro, what the fuck, dude? Cool. Alright, back to question 2 here. How many non-root, non-service, non-daemon users are there? Let's cat Etsy password here. So what we're going to do is just check to see if they have home directories here. So user bin, probably check home. They have one home. Users here. We have no home directories besides some, let's see, besides syslog, and that's not a user, so the answer is 0. What user is the app running as? So I believe we do a who is command, get www data. If it decides to work, or who am I? www data. What is the user shell set as? www data x3333, user sbin no login. So it's var www user login, user sbin login here. User sbin no login. It's going to be user sbin no login. What version of Ubuntu is running? LSB release -all. Distributor ID Ubuntu description 18.04.4. Codename Bionic. So 18.04.4 is the version of Ubuntu running. Print out the MOTD. What favorite beverage is shown? That's the header d.d/00-. And we are looking for the message of the day here. So create header of the MOTD, copyright 2009, blah, 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 free software, blah, blah, blah. Let's see here, any later version. Welcome to description, you name R. Dr. Pepper makes the world taste better. What is the favorite beverage shown? Dr. Pepper.